Okay, so as we start to move into a unit where we're only going to be solving quadratics, we want to make sure that we know how to go from vertex form to standard form. And we're also going to eventually talk about going back from standard form to vertex form. So it's important to recognize both are quadratics because both have the highest degree of 2. So they're both going to be quadratics. They're just going to be written in different formats. And as we pivot to this next unit, they are typically going to be written in standard form. However, we still will see vertex form. So let's write down these two forms, ax squared plus bx plus c, that's called standard form, and a times x minus h squared plus k. Notice that b and c and h and k are exclusive. They're not in the other form. The only letter that is in both forms other than x and y is a. A is still going to tell us all of the same things. A is going to tell us if it's a stretch or shrink. It's going to tell us if the parabola is facing up or facing down. So we do want to keep in mind that this is actually the same value. So that's really important. Before we talk about going back and forth between the two forms, I just want to quickly remind you about how to expand a binomial. Remember, this is a binomial because there are two terms. And we know that we are never going to just distribute the squared into the parentheses. This is not x squared minus 9. What it really is it's x minus 3 times itself, x minus 3. So one way we talked about multiplying this at the beginning of the year was using box method. X minus 3 times x minus 3. That gave us x times x, which is x squared, x times negative 3, which is negative 3x, negative 3 times x, which is negative 3x, and negative 3 times negative 3, which is positive 9. Giving us that it's x squared. If I combine my two like terms, that's going to be negative 6x plus 9. But as we do this more and more in this unit, and the fact that we're mathematicians and we're always looking to find a pattern to work smarter, not harder, let's see if we can't do this without even using the box method. So if we have 2x plus 1 times 2x plus 1, well, I know 2x is going to multiply by itself twice. That's going to, or multiply by itself. That's going to give us 4x squared. But then 2x is going to multiply by 1, and 2x is also going to multiply by 1. So 2x times 1 is 2x. But if that's happening twice, kind of thinking of our diagonal here, then that's really 4x in total. And then lastly, 1 is going to multiply by itself, giving me 1. So let's see, can we do 3x minus 4 in our head? 3x minus 4 times 3x minus 4. 3x is going to have to multiply by itself to give us 9x squared. Then 3x is going to have to multiply by negative 4 twice. So once would give us negative 12x, but if it's happening twice, that's going to really give us negative 24x. And then negative 4 is going to multiply by itself to give us 16. So it's 3x by itself, 3x and negative 4 by itself twice, and negative 4 by itself. See if you can try to start doing that almost in your head. That's going to make what we do next even easier. So this equation is in vertex form. Remember, our vertex would really be negative 3, negative 1, because plus 3 meant it went to the left 3, and minus 1 meant it went down. So that's where our vertex is. Good to know. And so now we have to follow Pemdas. So we have to do the exponent first. And so again, let's see, can we do this in our head? X is going to multiply by itself, that's x squared. X is going to multiply by 3 twice, and so that's going to give us 3x, but twice is 6x. and then 3 has to multiply by itself to give me 9. So I do the binomial first. I multiply that out first. And now my next step in Pemdas would be to multiply. So I'm going to take this 2 and distribute it to everything inside of the parentheses, giving me 2x squared plus 12x plus 18. And then the last step is to combine it with the like term of the minus 1. So 2x squared plus 12x plus 17 is our equation in standard form. Notice that a is still 2. So that number stays the same, but our vertex, -3, -1, doesn't show up in this equation. We'll talk next about how to find the vertex when it's written in standard form. So let's do one last one in vertex form. Y equals -4 times x plus 5 squared minus 6. So again, let's see, can we do this in our head? X is going to multiply by itself to give me x squared. 5 is going to multiply by x twice. So that's going to be 5x twice, which is 10x. And then 5 is going to multiply by itself to give me 25. Then I have to do my distribution. So I distribute the -4 to give me -4x squared minus 40x minus 100. And then at the very end, I need to subtract my 6 to give me -4x squared minus 40x minus 100.